In this video, we will learn about uneven numbers and odd numbers, highest common factor of 2 or 3 numbers using what? Prime factorization, multiples, and probably finding LCM and HCF of 3 numbers using prime factorization and division. And then we will draw a relationship between factors and multiples of 4 numbers from 1 to 100. So now let's start an even number. An even number is a number which can be exactly divided by 2. Example 2, 4, 6, 8, 10, 12, 14. So if you look at the example below, it means that even numbers are multiples of what? 2. Because 2 times 2 is 4, 2 times 1 is 2, and so on and so forth. So an odd number. An odd number is a number which is not exactly divisible by 2. It is a number which is not a multiple of what? 2. Example 1, 3, 5, 7, 9, and so on and so forth. So these are the even numbers. So let's look at the arrangement of array of some of the even numbers and odd number to enlighten us. Okay, so from the diagram, numbers that can be arranged in twos, that is 2 rows of equal number of dots, are even numbers. This one, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, this and that, 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 this and that. If they can be arranged in twos, that's 2 rows of equal number of dots, it means that that number is what? An even number. So, and from the chart we have what? 2, 4, 6, 8, 10. So 2, 4, 6, 8, 10 are even numbers. So numbers that cannot be arranged in twos are odd numbers, like this. This one, yes, we have 1, 2, 1, 2, 1, 2, 1, 2, and 1. We don't have its partner. So this number ceases to become what? An even number. So therefore it is a what? An odd number. Like, and this 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. There is nothing here. So it ceases to become an even number. 1, 2, 1, 2. There is nothing here. So it ceases to become an even number. And then 1, 2, 1, 2, 1. And then there is nothing here. So it ceases to become an even number. 1, 1, 1. There is nothing here. So this one is only 1. So uneven numbers start from what? 1, 3, 5, 7, 9, and so on and so forth. Okay, so now let's listen to some. When when they ask you to find even numbers less than 10, even numbers between 10 and 20, odd numbers less than 7, odd numbers less than 15, even numbers between 12 and 26, odd numbers between 21 and 43, odd numbers between 51 and 97, even numbers from 50 to 74. How do we do it? Let's take them one by one and then look at how we do it. Okay, so when you say even numbers less than 10, it means that you not get to 10, because we are looking for numbers that are less than 10. That's why we have 2, 4, 6, 8. So it's less than 10. It's not up to 10. So number 2 says what? Even numbers between 10 and 20. So when we say between 10 and 20, the moment you hear the between, the numbers mentioned will not be part of the answers. So you start from the next even number, which is 12, 14, 16, 18, and you stop, because it's what is between. We are looking for numbers that are between 10 and 20. Okay, and odd numbers less than 7. So less than is not up to 7. So you start from 1, 3, 5, and you are done. And then odd numbers less than 15 start from 1, 3, 5, 7, 9, 11, 13. And then even numbers between 12 and 26. Because of between, the 12 and the 26 will not be part of the answers. So you move, starting from 12, you move from what? The next even number, which is 14, 16, 18, 20, 22 and 24. Please, I want you to pay attention to the between, less than, and then more than. So between, you not add the numbers mentioned in the question, but if it's less than, you not get to the number in the question. For example, between 10 and 20, 10 was not included. We didn't include what? 10, and then 22, we didn't add it. And then the same thing here, between 12 and 26, 12 and 26 wasn't part of the answers. So odd numbers and even numbers could be generated by skip counting in twos. So in skip counting by 2, you jump over every other number. So skip count in 2 starting from 1 to generate odd numbers. Like this. You stand here, you jump, skip 1, 2. So this is 1, 2, and then you jump from 1, 2, 1, 2, 1, 2, and then 1, 2. So when you start from 1 and you skip count by 2, it means that you are finding what? An odd number. So from this from this number line, there's odd numbers are 1, 3, 5, 7, and 9. Okay, and then from skip count in 2, starting from 2. Starting from 2 to generate even what? Even numbers. So if you start from 2, 1, 2, 2, 2. Okay, so from the number line, the even numbers are 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. That's what from number 9. So we can use skip counting by 2 to find our even numbers and what? And odd numbers. Okay. So when you skip counting 2, starting from 1 to you are generating what? Odd numbers. And skip counting 2, starting from 2 to generate what? And even numbers. So highest common factor, that's HCF of 2 or 3 numbers using prime factorization. Okay, so before we determine the HCF of numbers, let us look at how to find the prime factors of numbers using what? The factor tree. So because of the shape of this thing, that's why we said what? It's what? Factor tree. Factor tree. Okay, so now if you have 24, you take a number, look for a number that can go into 24. 2 can go into 24 how many times? 12 times. And then a number can go into 12 how many times? 2 can go into 12 6 times. And then look for 2 can go into 6 how many times? 3 times. And let's look at 48. 6 can go into 48 how many times? 8 times. And then look at here, 2 can go into 6 how many times? 3 times. And 2 can go into 8 how many times? 4 times. And 2 can go into 4 how many times? 2 times. So 24, if you take the factors, that's, we know what is a factor. So we know that we know the meaning of factor. So we take 2 is a factor, 2 is a factor, 2 is a factor, 3 is a factor for 24. And then 2 is a factor here, 3 is a factor, 2 is a factor, 2 is a factor, 2 is a factor. So factors of 48, we have 2, 3, 2, 2, 2. And rearranging them, 2, 2, 2, 2, 3. It means that 2 times 2 times 2 times 2 times 3. Okay, and if you come here 24, 2 times 2 times 2 times 3. So when you are using factor tree, this is how you must get your what? Your factor, using the factor, you must get your HCF. So how are you going to find the highest common factors? The highest common factor of 2 or more numbers could be determined using prime factorization. So now we are come to find the HCF of 36 and 48 by using the factor tree to list the factors of each number. Okay, so when you have 36, you look for a number which can go into 36. Here 6 can go into 36 how many times? 6. So 6 can go into 36 6 times. But a number can go into what? 6. Which number is that? 2 can go into 6. How many times? 3. And then 2 can go into 6. How many times? 3. So 36, the factors are 2 times 3 times 2 times 3. And then if you rearrange them, you get what? 2 times 2 times 3 times 3. And then 48. Which number can go into 48? 6 can go into 48 8 times. And then this 6, 2 can go into 6 3 times. And then 8, 2 can go into 8 how many times? 4. And then a number can go into 4. Which number is that? 2. 2 can go into 4 how many times? 2. So you get 2 times 3 times 2 times 2 times 2. Rearranging it, you get 2 times 2 times 2 times 2 times 3. Now, you underline the common factors in each product. So 36, the common factor here is 2 times 2 times 3, and then 2 times 2 times 3. So the common factor is what? 2 times 2 times 3 here, and 2 times 2 times 3 here. And we take 1 out. So therefore, HCF of 36 and 48 is 12. Why is it 12? Because 2 times 2 is 4. 4 times 3 is 12. So highest common factor of 36 and 48 is 12. Okay, so let's look at another example. Example number 2. We have 16 and 20. 2 can go into 16 how many times? 8. And 2 can go into 8 how many times? 4. And then 2 can go into 4 how many times? 2. So factors are 2, 2, 2, 2, 2. So 16 we have 2 times 2 times 2 times 2. And then 22 can go into 20 how many times? 10. And then we know that 2 can go into 10. How many times? 5. So 20 we have 2 times 2 times 5. So now by underlining the common ones out. 16 we have 2 times 2. Yes. And then 2 times 2 in 20. So it means that 2 times 2, 2 times 2 are the common things out here. So therefore, HCF, highest common factor of 16 and 20, is 2 times 2, which is equal to 4. So the HCF of 16 and 20 is 4. Okay, so since we know how to find our HCF, let's go to multiples. So the multiples of a number is the set all the numbers obtained by multiplying the number by 1, 2, 3, 4, 5, 6, and so on and so forth. For example, the multiples of 2 are obtained as follows. You see, 2 times 1 is 2. That is 1. Then the same number, 2 times 2. 2 times this is what? 4. 2 times 3 is what? 6. So now let's look at the multiples of 3. 3, 3, 6, 9, 12, 15, and so on and so forth. Multiples of 4, 4, 8, 12, 16, 20. Multiples of 2, 2, 4, 6, 8, 10, 12, and so on and so forth. So, least common multiples, which is LCM, of given numbers is the smallest multiple which can be divided by the given number or given numbers without leaving what? A remainder. So let us use the prime factorization by inspection to determine the LCM, which is least common multiples of given numbers. So the question is, find the LCM of 36 and 48. As we did for factor 3, 2 can go into 36 18 times, 2 can go into 18 9 times, a number can go into 9 how many times? If each number is 3, how many times? 3 times. And then 48, 2 can go into 48 24 times, a number can go into 24, which is 2, 2 can go into 24 12 times, a number can go into 12, 2 can go into 12 6 times, a number can go into 6, which number is that? 2 can go into 6 3 times. So on circle ones are the factors that we are looking for. On circle ones are the factors that we are looking for. So 36, 2 times 2 times 3 times 3, and 48, 2 times 2 times 2 times 2 times 3. So okay, then multiply each factor the greatest number of times it occurs in either number So if the same factor occurs more than once in both numbers, multiply factor the greatest number of times it occurs. So if you look at this, 2 occurred twice in 36. 1, 2. 2 occurred twice in 36. And 4 times in 48. 1, 2, 3, 4. So we pick the 4 occurrences. So we will pick what? This one, as we have done it here. 2 occurs in 36, 1, 2, and then 2 occurs in 48, 1, 2, 3, 4 is 4. 2 occurs in 48 is 4. So we will pick what? The 48. Okay, so 3 occurred in once. 3 occurred once in 48. 3 occurred once in 48 and twice in 36. So we pick the 2 occurrences under 36. So here 3 occurs here, only 1. But in 36, 3 occurs there. So we will pick what? The 3. So the highest one here is what? 3. So the LCM is 2 times 2 times 2 times 2 times 3 times 3, which is the 4 twos here, and then the 3 twos here. I mean 4, 1, 2, 3, 4, 1, 2, 3. When you multiply them, you get what? 144. 144. So you check to verify if 144 can be divided evenly by 36 and 48. So if you get it, it means that your 144 is correct. So let's do another example and see for more understanding. So find the LCM of 30 and 45. As usual, you find a number which can go into 45. 3 can go into 45 15 times. And we can see that a number can go into 15. How many times? Which number is that? 3. How many times? 5. So we get 45, 3 times 5. And then 30, 2 can go into 30 15 times. 3 can go into 15 5 times. So you get what? 2 times 3 times 5. Okay, now so you take the common one out. The highest here, the 3 occurred here how many times? Twice. And then it occurred here how many times? 1. So you take what? The highest one. And 2 occurred here 1, and then we do not have 2 here. So the highest 2 here is what? Only this one. Okay, 5 occurred here and 5 occurred here. So we will take 1. That's why we have 2 times 3 times 3 times 5. So 2 times 3 times 3 times 5 will give you what? 90. So therefore LCM of 30 and 45 is 90. So let's look at where we will use what? The Venn diagram. Okay, so using Venn diagrams to find the HCF and the LCM of numbers. So let's find 36 and 48. So factors of 36 are here. Factors of 48. So the middle one is the common one. The 2, 2, 3. They are the common ones. 3 here is not common. That's why we do not have any numbers here. But the common ones are the intersection. So we call this one intersection. So this is factors of 36. So from here are the factors of 36. So anything within this circle are the factors of 36. Anything within this circle from there to this place are the factors of 36. But the common ones are the 2, 2, 3. Okay. So the HCF is obtained by multiplying the factors in both circles. So you have to multiply 2 by 2 by 3 before you can get the highest common factor. So only the HCF is what is found by multiplying the numbers in this circle in the intersection. But the LCM is found by multiplying all the numbers 3 times 2 times 2 times 3 times 2 times 2. You get what? Your answer. So 3 times 2 is 4 times 3 is 12, and 3 times 2 times 2 times 3 times 2 times 2 is 144. So this is how we use what? Venn diagram to find our HCF and our LCM. So in terms of finding LCM and HCF of 3 numbers using prime factorization and division. So the following steps are followed to calculate the LCM of numbers by division method. So 1. Write all the given numbers in a single row. 2. Find the least prime number that divides at least 2 numbers from the given numbers. 3. Write the quotient exactly below the respective number. The numbers which are not divisible by that prime number have to be written as they are being below and then the respective number. 4. Repeat step 2 until no two numbers are divisible by the same number. So 5. Multiply the divisors and remaining quotient to find the LCM. The product of all is the LCM of the given set of numbers. So these are the steps that we used to do the factors of what? The LCM of 36 and 48. So let's go to the relationship between factors and multiples of whole numbers from 1 to 10. So the factors of a number are all the whole numbers by which the number could be divided with no remainder. So factors of 6 are 2, 1, 3, and 6. Factors of 6 are 1, 2, 3, and 6. So let's go to properties of factors.